Hey, good morning, folks. Today we're going to spend another day with rhombuses and squares. We're going to try to prove that they are rhombuses or squares or both. And we got to use these properties right over here. So I'm going to walk you through a couple. We're going to do the first homework problem together right here in the video. The video is made more for those that are absent in class. We're going to talk about this as well. So first of all, let's look at one of the problems from last night before we dive any deeper into proving something is a rectangle or a rhombus or square. So this problem had, 4 points. And first thing I need you to do is to graph those 4 points. Okay, so let me go back and just kind of label some of them to make sure I've put them in the right spot. So here's negative 2, 1, right? And then here is 0, 2. This is 0, 2, up 2. That's the y value, right? Over to the left and right, none. So I didn't go left and right at all. I just went up 2. Here is 2, negative 1. So 2, negative 1. And then down here, we got 0, negative 4. So I definitely graphed them correctly, right? The next thing I want to do is see, is this thing even a parallelogram, right? I mean, if it's not a parallelogram, there's really no reason to keep investigating whether it's a rhombus, rectangle, or a square. It'd be none, right? If it's not even going to qualify as a parallelogram. So let's look at the slopes of a couple different sides. So let's look at the slope of this side right here and see if it's the same as the slope of this side. So one way to do that, right, is to figure out what the run is and then what the rise is. So the rise, so let's do the rise first because, slope is rise over run. Oh, and let's put some letters on there. So this is A and then this is B, right? So the slope of AB is equal to a rise of, let's see, we're at negative 1, we're going up to 2. So that's a rise of 3. And if you're like, why isn't he using the formula? We could say 2 minus a negative 1. That's where the 3 comes in for the rise, right? It's one y value. Usually they say y sub 2 minus another y value, like y sub 1. And so that ends up being 3. And then the run is over 1, 2, right? We're going over 2. That's like going from, let's see, how do I want to show this? Negative 2 to 0, right? So I could say like negative 2 minus 0. Well, actually, I went like this. I went 2, see this 2 right here, went 2 minus a negative 1. So I need to really flip these two around right here because you can't switch the order in which you subtract them in. That's where like trying to go back and use the formula is a little tricky because I know this is going to be a positive slope, right? Because look, that's what a positive line does. It goes up from left to right. It's increasing. So I've got to continue going 0 minus a negative 2, the same direction I subtracted the other. 0 minus a negative 2, and I end up with a positive 2 down there. So I have a slope of 3/2 there. That takes a long time to kind of show all that. So I'm just going to do it a little bit faster here. The slope of this one right down here. What are these letters again? This is C right here, I think, and then this is D down here. So I'm going to say DC. And what do I get for a slope there? I'm going up 1, 2, 3 over 1, 2. So I've got a slope of 3/2, right? Let's do the slopes of these guys right here. This is AD. So we got AD is a slope of, let's see, we're going over 2 and down 1, 2, 3. Okay, so that would be a negative 3 over 2, right? The slope, the rise is down 3 and the run is over 2. And then this one over here is down 3 and over 2. So let's see, what are the letters on that? BC. BC is 3 over 2, negative. All right. So let's see. Opposite sides. These opposite sides have the same slope. That means they're parallel to each other. These opposite sides have the same slope. So that means they're parallel to each other. So we definitely have a parallelogram over here, right? So check mark, parallelogram. Now let's see if the thing is rectangle, rhombus, or a square. Well, it's definitely going to be a rhombus for sure because the diagonals are perpendicular to each other. So when I look over here, if the diagonals of parallelogram are perpendicular, then the parallelogram's a rhombus. Check mark. I'm using that one right there. How do I know they're perpendicular? Well, look, we're going totally horizontal to get from one point to the other. Here we're going totally vertical to get from one point to the other. So these two slopes are completely opposite from each other. it's kind of hard to say because this one's undefined, this one's zero slope, but they're definitely perpendicular, right? I mean, horizontal and vertical. So anyways, we now have a parallelogram. It's also we just said rhombus because the diagonals are perpendicular. Can we show that it's a rectangle? Well, in order for it to be, well, if it was a rectangle, also, it would be a square too, because all four sides equal. That's what a rhombus means. Four sides equal. Now, if we get right angles, four right angles, then we have a check on the square too. So let's look at the right angle idea. Does that look like a right angle? Well, I don't know. You can't go by what it looks like. So let's just write the slope right down here again. This slope was -3/2. And this slope over here was +3/2. Shoot, I don't like that little tick mark right there. +3/2. In order for them to be perpendicular to each other, the product of the two slopes needs to come out to be -1. Let's see what happens when I multiply the two together. I end up with -9/4, which is the same thing as -2 1/4. You might say, what is he talking about? He's never said that. What I have said is that they need to be negative reciprocals of each other, the opposite sign and reciprocal. So like if one of the slopes, like if that slope, let's say we flip it over, we take the reciprocal and we write -2/3, okay? If that slope would have been -2/3 and we multiply it by 3/2, watch what happens. If we multiply those two together, we get -6/6, which is -1. See, that proves something is perpendicular. If they're two slopes multiplied together, give you -1. All right. So the sides are not forming a right angle. So I'm going to put a little line through rectangle. As soon as I put a line through rectangle, I've got to put a line through square because all four angles are not equal. So this is only a rhombus. So right here, we should have a drop down on rhombus. And then over here, we should have like, something about diagonals are perpendicular. All right. Or they might have all the sides are equal because, if we're going over by 2 and up by 3, the Pythagorean theorem would give us some length that's the same as this side over here's length because that slope was the same. And then this one over here would have the same as this one over here because, again, the Pythagorean theorem, right? So it might say right over here, all four sides are equal to each other, all right? So I hope I made that one clear. Now, we're going to look at a proof in video 2, but I just wanted to stop there. In video 1, I was reviewing one of the problems from homework last night, and we used this property right here. In video 2, you're going to see me prove that this thing right here is a rhombus because of this theorem right here. If two consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So remember this one right here, I had to first show that the thing was a parallelogram. Let me see if I can come down here and highlight that idea. First, I had to show that it was a parallelogram. Then I could show it was a rhombus. So in my proof over here, I'm going to do kind of the same thing. At some point, I'm going to say this thing right here is a parallelogram. All right. And then we'll go beyond that and say that it's a rhombus. Hey, thanks for watching video 1.